Welcome to the Polymer Science Podcast. I am Dr. Alicia Buertes.
And I'm Jacob Scheckman.
In this podcast, we'll be speaking to researchers from around the world and talk to them about how their work is improving our daily lives. I hope you enjoy our conversation and that you learn something new. Hello everyone, welcome to another episode on the Polymer Science Podcast. Today we are talking to Adam Hecht. He is the co-founder of the company called DiveDesign, and his company focuses on helping businesses navigate and access the benefits of 3D printing. Adam Hecht is passionate about 3D printing and has developed so many products using a 3D printer, such as prosthesis for a man's best friend, and furniture, as well as pulling out trash from the ocean and changing it into something that is beneficial and useful for society. So he'll be talking to us a bit more about 3D printing today and explaining some of the additional features that goes into developing some of the products that he has made with his company so far. He especially speaks about TPU and TPR, which is thermoplastic polyurethane and thermoplastic rubber, and how he utilizes this in prosthesis. Hope you enjoyed this episode. Let me know what you think in the comments and share this episode if you enjoyed it. Thank you for listening. Welcome, Adam Hecht, to the Polymer Science Podcast. Thank you very, very much for joining us for this episode. So you are the co-founder, designer, and director of additive manufacturing for a company called DiveDesign. And you're currently residing in New York, correct?
Yes, actually. Well, first of all, thanks so much for having me. We're just outside of New York. We're in New Jersey, but right on the border, so you could go either way.
Awesome. Could you just please introduce yourself to the listeners out there and tell us a bit more about you?
Yeah, absolutely. Well, my background's in industrial design, so not exactly polymer science, but it's been a very big part of the journey, as I'm sure you've seen. But we really started Dive as a way to get involved in a range of different products and technologies, and it's really grown the past few years in a lot of interesting directions, primarily around additive manufacturing, and that's really what we do today, is in helping companies to utilize it, creating our own products and brands that utilize it, and really helping to share and tell all the amazing stories happening in the field. So our goal is really to help accelerate the adoption.
Awesome. So you work with 3D printing and designing and making things like prosthetics, for instance. But you also, like I mentioned, you founded your own company, the DiveDesign. And I'm very curious to know, just in general, how did you manage to get into polymer science as a field? And what led you to co-founding this company?
Yeah, well, I guess starting with founding the company, to give a little bit more context, my partner and I really started out of college just doing freelance work, a lot of industrial design, freelance, helping local startups and inventors to prototype ideas and validate them and bring them to market. So we were kind of all hands in a bunch of different areas, just surrounding product development. And through that, and through some really interesting people we met, we learned about the animal prosthetics field and started to see, how far behind it was to human prosthetics and the devices they were making. And it was really interesting to us because a lot of the processes and tools were very labor intensive, really manual. And, as us as two outsiders that were a little bit, I think, naive to what was possible at the time, we thought, we're 3D printing prototypes in school. I mean, we're making like small plastic parts, nothing exactly functional, but maybe there's a way we could help with 3D printing. And that's kind of what led us to really look into the polymer side, the materials, what was possible, because we didn't really have any reference. Like, people weren't even really printing human prosthetics at the time, other than just like behind the scenes prototypes. So that was our our debut and looking into what was possible and what got us really interested in the material science behind it.
Wow, that's awesome. And then in general, how did you find polymer science? How did you get into that field? Like, when did you feel
I really want to go further into science and that type of research?
It was kind of necessity out of the products. I wouldn't say we're exactly polymer scientists ourselves, but we've worked with many, because when you're trying to solve old problems, or identify new applications, you can't always use, what's available today, especially with 3D printing being such a new industry. There's still, so many materials and so many opportunities to come. We're still kind of just scratching the surface. So, we have to work very closely with our partners on the material side to really help co-develop new solutions, new blends. Some of our applications are really unique compared to what people have been using 3D printing for in the past. We're not just looking for rigid parts for jigs and fixtures, or we're not just looking for really high detail plastics for models. We're looking for things that are flexible and impact resistant and, can really survive out in the real world. Things like for dogs, for example. I mean, everything to them is a chew toy, right? So how do you make sure that not only does it survive its intended functionality, but also as a chew toy? So, we really have to dig into the science behind it and say, not only will this survive as a product, but is this safe? Is this, is going to cause any harm? So, the polymer science conversations, it's a really important one, especially with living creatures.
That's awesome. Now you've mentioned, this is not a tough topic that I really want to get into with you. There's a few other things I want to talk to you about as well, but you are currently, or you have made prosthetics for man's best friend, dogs, and I want to know more about that. Like, what goes into the whole process of developing a prosthetic limb for a disabled animal like a dog? Please tell me more.
Yeah, sure. So, I guess to start, we can take a look at the conventional process. And this is, the process they were using for dogs is also very similar to what they still use for humans, where they're basically taking a cast of a limb, wrapping it with a tape, almost like if you ever broke your arm and you got a fiberglass cast. It's like the exact same material that they'll wrap the limb with. And again, whether it's a human or a dog, same process. They take it off, they fill it with plaster that then hardens, and then they're able to sculpt that and make modifications and smooth it out before they take either a thermoset or a thermoformable plastic to heat up and pull over it, almost like vacuum forming.
Okay.
That's how they make plastic devices. Or they're using resins and composites to make a really, really durable socket or shell that's going to perform a lot better than a polymer for certain cases. But these processes it's almost like an art form, right? You have to really be skilled in not only like the steps, but also the muscle memory to create these. So it's a hard field to break into. It takes a lot of training, and the process itself, even when you are an expert, is still very messy and time consuming. And, there is still a lot of like risks and failures involved. So when we came in, really looked closely into what they were currently doing, breaking it down step by step, and at every part of the process asking why are they doing that and how can we bring digital technologies into the picture. Because obviously anytime it's digital, there's no waste, there's no lost parts and pieces, there's no the challenges that you see with working directly in the plasters or plastics. And from the first step, from the casting, we're already able to incorporate things like 3D scanning. When we have dogs come in, we're able to directly 3D scan them using something as simple as an iPhone. Wow. We're not using $10,000 scanners that they're using in these clinics because there's no need for it. There's a lot of clinics realizing that as well on the human side, that they can just use an iPhone.
That's amazing.
It lowers the barrier. Right, so it's not only lowering the barrier for animals, but also on the human side, especially in developing countries. So, we basically look to the latest and greatest at each step, starting with the scanning. We're able to take that scan and bring it into another software where we're able to create a custom design automation algorithm. Because anytime you create something custom, if you're using conventional CAD tools, you're kind of starting from scratch each time.
Nice.
Where when you're making many custom devices, you need to automate that. Otherwise, you're, again, starting from scratch with each design, which it's not scalable. It takes too long, too many variables involved. So we were able to create really an automated workflow for that, where the computer does most of the processing. We're able to identify, all right, there's a leg here, there's not a leg here, this is how the alignment should be for the specific pet, and the computer will compute the rest from a few basic inputs. So it's a fairly fast process. And then from there, it's sliced, it's basically put into a software that breaks it down layer by layer for the 3D printer to read. And then it prints overnight. They take between 15 and 24 hours, depending on the size. Yeah, so it's, instead of a ton of hand labor and wasted material supplies, we come in the next morning, it's ready to go, and we clean it up, assemble it, and we'll do the fitting with the pet, or we'll send it out anywhere in the world.
But it sounds like a lot of optimization went into the process, and now it's running nice and efficient. So well done.
Yes, absolutely. It was a heavy lift to get started. A lot of prototypes, especially on the material side. That was the biggest, because we knew how to scan, we knew how to design it, we knew how to automate those processes, but we didn't know, and nobody at the time really knew how to print something that large with the functionality we needed for that price point that we were trying to serve. So it was really the material that took the longest to figure out. I mean, it's a funny story how we actually found the right material. We had just started the business, and we didn't have any funding. We were starting out of a basement, and we had one printer, and we had PLA, like the most basic 3D printing material.
Okay.
And we saw on Craigslist somebody was selling an entire trunk of materials. They were getting rid of all their 3D printing stuff. So we took a subway out to Brooklyn and picked up a huge bin of every kind of 3D printing material, things we'd never even heard of. And one by one, we went through at least 40 different options over the span of weeks trying to identify the right one. So it wasn't exactly a science to start. It was just, try everything and hopefully we'll find the right answer.
Well, that's the best way of doing it sometimes, and the way you discover things. So. Wow. Yes. But that brings me to my next question, like what type of polymeric material did you decide on eventually? What seems to be working the best for being safe for the dog, flexible but hard enough, as well as being a chewable, side snack for the dog?
Yeah. Absolutely. I wish I could say that, we thought about those qualities and the perfect material was right there, waiting for us, but with this product being something that was previously made out of polypropylene or carbon fiber, that's kind of where we tried to start. We were thinking, all right, let's the ones that people had made in the past were using these materials. The challenge was they could only make one or two a month because they would take 15 to 20 hours to make a piece. So we thought, let's start there. And polypropylene at the time was almost unprintable just because of how it contracts. We print especially complex geometries, even though it had the flexibility that we needed. Carbon fiber materials were, they were very strong, but they were also brittle because it wasn't continuous strands of fiber. And we had industrial, companies trying nylons and every material with us. And then finally, it was, one of the half-empty spools in the bottom of the barrel that we were like, hey, let's try this for something. Somebody asked for a duck prosthetic. And we thought maybe this flexible material would work for the duck. It was bright orange, a perfect match. And we tried it, and we felt it, and we realized, wow, this is really flexible here. But the other parts are really stiff. It almost feels like nylon. Maybe we can balance it out to have flexibility in some areas but rigidity in others, and that's when the switch was flipped in our minds when we realized TPU was like that perfect material. And then it just so happens that, of course, so many dog toys and other dog products are made of like TPU and TPR and like this flexible, chewable, really strong material. We realized how widely it's already being used, but we just didn't think about it initially because they weren't using it for prosthetics. Nobody's, other than like flexible liners for certain sockets, like nobody's using flexibles in the prosthetics realm like that.
Wow.
So it took a little while to get there, but finally we did.
This is so interesting. And we're not going to gloss over the fact that you had to make a prosthetic leg for a duck. That's awesome.
Yes, yep.
That's so cool. Is it like a real duck, like a live duck, or was it for a toy or? An actual
No,
duck that
it was
needed...
a real duck with a missing part of one of the limbs, and we were able to. It was just one of the first non-dog cases we did.
That's so amazing.
It was just, it was amazing. The duck took off running for the first time. Like everybody was in tears. Yeah, it was amazing.
That's so sweet. Is there any other animals that you have worked with besides dogs and ducks?
Everything from numerous ducks to goats. This is a helmet for a goat that we did. It's the same material, very flexible. It was for a goat that had a hole in his skull.
Oh,
and of course,
goodness.
Goats are headbutting everything, so they wanted something to protect it. So we use that same really impact-resistant, flexible material. And we've done tortoises, really big carts for really huge, I think it was 100 pounds, missing front legs.
Oh my goodness.
We've done little wheels for really little turtles. And we're currently working on a prosthesis for an elephant.
Wow. Okay.
That's being printed today, so that's an exciting one.
Wow. That is quite fascinating. I imagine that takes a couple of kilograms of plastic or more.
Yeah, I think it came to around 5 kilograms.
Goodness.
So it's the part of the device that we're printing is what they call a thigh cuff. It's a flexible cuff, ultimately, that goes around the thigh of the elephant, and it helps to hold the carbon fiber prosthesis in place. It's hard to keep with such a big animal. You really want to make sure that the prosthesis doesn't fall off.
Exactly.
It's really important that it stays on out in the wilderness. And so this is a really big flexible collar that is going to help to keep it suspended. And they said, that flexible material is perfect because they're fitting it in Sri Lanka. And so they're like, we really have one shot for this. If it's a little bit too small or too big, it's not going to work. So because it's flexible, it really conforms very, very well to any deviations in size.
Wow, that's actually so fascinating. Wow.
Yeah.
So have you met the elephant, or is it?
I have not, unfortunately, but my partner Alex is actually going out with the crew to Sri Lanka in a few weeks, so he'll get to meet the elephant.
Oh, wow. So I wanted to know also the cost efficiency, when you compare this to other prostheses, how does it compare?
Yeah, it's, as far as material goes, typically extruded materials are a little bit less expensive than getting a big sheet of polypropylene. And one of the reasons is because we have a lot less waste. So to make one prosthesis, the conventional approach, or for humans, you're basically using an entire sheet and then cutting all of the excess off, just leaving the little remaining section that you used. So even though the material cost, ounce to ounce is comparable, we have to use a lot less of it. So that's been a really nice added benefit of using 3D printing. The other nice part is the fact that I don't know if you can see, but it's hollow on the inside. There's a lattice, so it's really a what we call an infill. It's mostly air, so there's no dense material. So we're really able to cut down on the materials used, which helps to save a lot of cost, and it's also better for the environment, less waste. There's a lot less cost involved as far as actual labor. These previously took 15 to 20 hours to make by hand. Like I said, we're down to 3 or 4 hours a piece of actual physical labor of design, post-processing, setting things up. So we've really been able to dramatically cut costs and time associated. For us, the biggest factor, the biggest cost was the initial development. It wasn't just a new product. It was an entirely new system with multiple technologies that had to really be developed to get started. So for us, it was really, and for a lot of people with 3D printing, it's the initial investment.
That's true.
But now that it's up and running, it's become very, very efficient, very scalable. We've gone from helping the clinics that were originally making 1 or 2 devices a month to now doing upwards of 30 across only a handful of 3D printers. So it's been very scalable. And because of that, we're hoping to get more involved in more, not only more countries, but more clinics and veterinary offices. So
Oh, yes.
it's been really exciting because of that.
That would be amazing. So DiveDesign has also done many other things besides prosthesis. You have in particularly made like furniture and other types of collaboration with other companies. Can you tell me a bit more about the 3D printing projects that you have done with other collaborators?
Yeah, so we really like collaborating with 3D printing material or machine companies because we find that, well, personally, like we really believe that 3D printing is such an interesting, like fascinating industry. Like it's just one of the coolest things. And yeah, we're a little bit biased, but you know, I can definitely attest that other people think it's really cool as well. You know, that being said, like the marketing, the storytelling around 3D printing, we just felt wasn't really very good. It wasn't very transparent or, you know, authentic to the reality of utilizing it. You know, just kind of felt behind in the times. And as a company that's completely focused on applications, design, engineering, but also being designers and, you know, storytelling being such a big part of what we do, you know, we thought, hey, there's got to be a way to bring more light to the really cool applications that don't really get talked about, or can't be talked about, right? That's a big problem in the industry. Like they might have the coolest application, but they're not willing to talk about it, so nobody knows really how amazing the technology is. So, you know, we started to build relationships with these companies to say, hey, let's help to facilitate these projects. Let's help to find really interesting companies and applications and be at the intersection of not only solving real problems, but also doing it in a way that we can talk about it, to get other people inspired, to get other people, you know, giving it a try when, you know, we know firsthand just how much potential there is. And it's led to a lot of really fun projects. Like we just did a really big group of projects for a trade show. Everything from full-scale 3D printed furniture to parts for robot dogs that are used for like patrolling remote, you know, properties, and you know, hydroponic like plant towers for indoor gardening. Like all of these really fun applications for real companies that previously were like, 3D printing is, you know, it's not a real thing. Like it's for toys and prototypes. You can't print, you know, actual furniture or, you know, actual like housings for electronics. So, you know, we got to really change a lot of people's minds and solve some actual problems doing so.
That's true. I feel beforehand, like what you mentioned, 3D printing for me was also just for like, okay, so we need to replace the plastic lid on our doer system or something. So let's print that, or, you know, let's print a character for someone's birthday or something like that.
Yeah.
But the prosthesis, that part, when I heard about it, I was like, that opened up a whole new idea of 3D printing for me. And that's just amazing how you just made it grow into something more like that. So that's fascinating. So you've this is this one particular thing that you've also done where you collaborated with someone using filament made from fishing nets that you pulled from the ocean, and ideally then turned trash into something amazing that you could utilize again. Can you tell me a bit more about that?
Absolutely. So, you know, I definitely wasn't the one that personally, you know, pulled the nets from the ocean. But there's a company in Europe. I think they're in Amsterdam or the Netherlands. I could be totally wrong on that, but they're called Reflow, and they're dedicated to making filaments and 3D printing materials entirely out of different waste streams. And one of their newest materials, it's called Ocean RGFPP. It's a glass fiber reinforced polypropylene. It's made from like 75% recycled fishing nets that another company they partnered with was able to extract from different pollution patches in the ocean, and they convert it into actually a really, really good filament, because polypropylene itself has been, for years, really tricky to print. This one's not only polypropylene, it's made from garbage. And it's been, when we heard about it, we were like, we have to try this. We have to do a project with them. We have to talk about it, because it's just so exciting. Like the fact that you can take literally garbage and make something that, you know, I think personally I believe it's really beautiful. I haven't even posted the final pictures of it yet.
I was gonna ask. I still don't know what the product is.
Yeah. So by the time this comes out, I'm sure it'll be out. But it's a small piece of furniture. It's a small side table.
Oh, that's so cool.
And you'll see when we post the pictures, like the unique approach we took to it, because it's 3D printing. Because we're not just making the exterior of the part; we're designing the interior. We used a really cool translucent tabletop, and it almost creates like an infinity effect as you look into the inside.
Oh, nice.
And you see all of the detail from above, the way the light refracts through it. It's just a really neat piece, and I think it's just a testament to what you can do with waste, what you do with garbage, and repurposing it, just how much potential there is for it.
That's awesome. So just in terms, let's just get a little technical about the actual 3D printers. I don't have a lot of knowledge about 3D printers myself. We just got we just got a Creality Ender 5, I think it is. Mm-hmm. And we've only printed a PLA bunny with that one so far. And a small model of an ectoceratin, because that's what we do here. We analyze and do single particle analysis and so on. But can you tell me a bit more about the machinery that you work with and the type of 3D printers that you have, and how many are dispersed in your company?
Absolutely. Yeah, we started with one printer. I had it in my bedroom during the pandemic, and now we have like 16. So the past 2 years I've been busy, lots of printing, lots of new applications, and for us, being that we're a startup, being that we're completely bootstrapped, for us it was every decision we made was out of necessity and was just enough to get by. We never invested in anything more than we immediately needed. So basically, we didn't get a new printer until it had paid for itself.
I see.
And that's the really cool part about 3D printing, and being able to start with a $400 machine that paid for itself after like 1 or 2 prints. I mean, it's just a really cool thing to see happen. Over the past few years, we've been able to really strategically scale different sectors of our production facilities. So on one hand, we have machines for the animal prosthetics that do very well with TPU and other flexible materials. And then we have machines for more technical, higher detail parts like resin printers, where we're able to use different resins to print very accurate prototypes. Not always the most durable materials, but when you need a really good representation of tolerances before you maybe use a more expensive process, we're able to utilize those. And then we have much larger machines now for things like, you can see behind me, the 3D printed tree that's about 14 feet tall. So that's another class of 3D printer. Also a FDM, or filament fed system, where it's basically like a giant hot glue gun that just, the layers are like, the largest we've done are like 8mm wide layers in a single pass. So it's like a really big hot glue gun, which enables us to print very big pieces very quickly. And no, it's not the highest detail, but for certain applications, you don't need that detail that you would for a resin printer. So the reason we have so many different types is for all the different applications. Each is, you got to use the right tool for the job. We're hoping to continue growing our capabilities and what we can work with.
That's awesome, yeah. Is there anything else that you are currently working on, or that you would like for the listeners to know about? And where they can find you on social media, perhaps, as well?
Yeah, absolutely. Well, we talked about Dive, we talked about 3D Pets. The latest endeavor is definitely the tree you see behind me. This is a brand called Willow, where we're really hoping to begin to create more innovative, sustainable furniture for commercial spaces, because there's just, I think, not a really good conversation around sustainability when it comes to these larger spaces. With 3D printing, we're able to use these waste streams to create these pieces on demand, one at a time, without waste, without shipping extensive distances for molded parts. So it's something we're really excited about. Our first product is for the purpose of sound absorption, helping with acoustic dampening and helping to bring in, I think, better ambiance to certain spaces rather than just using flat panels on a wall. And we're hoping to introduce other commercial furniture pieces with that. And we just launched about a month ago, so it's been an exciting new journey for us as we continue to build our own brands. If you're looking to learn more about Willow, it's willow.design. Our socials are, I think, it's at willow.design.us. For Dive, we're Dive Design Co. And for 3D Pets, it's at 3D.pets.
Awesome.
Yep.
I'll also add all that links in the show notes so everyone can go have a look about it.
I appreciate it.
Thank you very much for your time and for talking to us about all this and all your projects. It's really, really interesting, and I love the work that you're doing. It's very, very amazing.
Well, thank you so much. I really appreciate you having me on the show.